Lab 1 will cover Riemann sums and integrals. If you have done Jupyter-based lab in Calculus 1, then this lab is very similar to the Lab 6 there. However, some of the problems will be a bit different. The material for most of the problems have been already covered in Lab 0. However, we still need to talk about on how to create subroutines for Riemann sums. There is a subroutines that will graph the Riemann sums and calculate the area. Pay close attention on how to do this because in the actual problem sets, you will be asked to write a few of your own subroutines. So we will start as usual with all the needed libraries, and next we will talk about subroutines. So the first subroutine we will do is the left box. This will be Riemann sum using left endpoints. Notice it has 4 inputs and the order of these inputs will matter, so we need to remember that. First 2 inputs A and B, this is the interval on which we will do the Riemann sum. Third one, capital N, that's number of subintervals we will take between A and B. And finally, f is the actual function, and this will be the numpy type of a function. So the first thing we do in our subroutine, we will set it up. We calculate delta x. We then get all of our endpoints, so our xi's. That means we will take interval from A to B, and we will take n plus 1 points there. It's n plus 1 because we have both A and B included for now. Then capital X and Y are just normal points to draw the graph of a function f. Now we want to only take the left endpoints of each subinterval. So we'll take all the x's, but we will skip the last point, b in this case, so the rightmost point. We find their values, so y left, and we calculate the area of all the rectangles. So the area of one rectangle would be y, which is the height, times delta x. We will need to add all of them, but since all the delta x's are the same for each subinterval, we can just add all of the y values first and then multiply by delta x. Then we will plot. So we'll create our figure, we plot our graph in blue. Then we will plot each point x left and y left on that graph, and we will make them a little bit bigger so we can see them. And this is our rectangles. So we will use a bar chart here. So x left and y left are endpoints. Width is how wide is this bar chart. A line edge tells us what point should we use as the height of the bar chart. So if we use edge here, that means this x left, y left is the height of our bar chart. If we skip here, if we don't write anything for a line, it will use the middle point of each bar chart, which will be useful for your assignment. We have a title, so we will use a left Riemann sum, and then we'll write n equals something here. So when you actually create a title here, instead of these curly brackets, it will write whatever n is. So if I change the n, I will have a different number there each time. We draw our graph, and then we also underneath will print the area. So we already calculated what area is in a setup, so it will write the number. And we will also do the right box. It's more or less the same thing. There are only 2 changes that I need to point out. The first one is instead of using x left, y left, we're going to have x right, y right. And so notice I'm going to take the same lowercase x's, but in this case I will remove the first point instead of the last point. So I only will have the rightmost points of each subinterval. And the second thing I need to point out is the actual bar chart. If I just use X right and Y right and rewrite the original command from the left box, it will use these 2 points as the left endpoints instead, which is not what I want. To fix this, I will use negative width. So notice my width is negative delta x. And so in essence, what it will do, it will use x right point as your height and end of your bar chart, but it will subtract the width now to create the actual bar. So x right is actually will be the right point. And the rest is exactly the same. So now let's look how this works. I will create a function minus x squared plus x. I will have an interval from 0 to 1, and I want to draw both left Riemann sum and right Riemann sum with n equal to 8. So it's 8 subintervals. So first thing we do, we create our function, minus x squared plus x. I will have to lambdify it so that it's a numpy function, and I'm going to call my subroutine. So first one I will call is the left box, so it's a left Riemann sum. Notice the order of my inputs here have to match the order of inputs I had. So the first one will be A and B, so my interval from 0 to 1. Next one is the number of subintervals, capital N. And finally, my function, in this case it's Fn. So let's call it. And here's my result. So as you can see, the title is left Riemann sum n equals 8. I have my graph in blue. These are my endpoints marked to make them look bigger. And then I have the actual rectangles, my boxes. So my first one has height 0, so you don't. And now let's find the actual area underneath the graph. So we will use a simple library to do integration here. It's quite simple. So we will use command integrate. The first input here is the function. It has to be a SymPy type of a function. And then the second interval is actually a 3-tuple. The first entry here is the variable with respect to which we are integrating, so x. And then the next two is the interval. So we will integrate this from 0 to 1. If we replace this whole tuple with just x, then it will be indefinite integration. But in our case, we want a definite integration. Let's run it. And as you can see, we got 1/6, which was what we guessed. Quite often, these answers might be quite unwieldy. And so don't forget, we can always use sp.n to rewrite our answer in a decimal notation. So here we go, 0.16 repeating. Lab 1 will consist of 4 problems. The first 2 problems will deal with Riemann sums using left or right endpoints. For these 2 problems, you are allowed to copy the subroutines from the example file. In the problem 3, you'll have to create your own subroutine that uses a midpoint rule to graph and calculate Riemann sums. And finally, problem 4 will deal with modeling that involve integration.